Picture this, you're in middle school enjoying your summer break on a warm day in the beach. You're collecting colorful shells with your friends and admiring their intricate beauty.
But what if we told you that in the near future, an experience like this might seem like an urban legend? In order to understand why this is, we need to learn about acids and bases. When people think about acids, they tend to think of liquids that are capable of melting through anything in their path.
Like the bathtub scene from Breaking Bad.
Exactly. But what if I told you that even this was an acid?
So then, what even is an acid? Acidity is measured on the pH scale. The pH scale ranges from 1 to 14, with 1 being the most acidic and 14 being the most basic. An acid is anything of a pH less than 7 and donates a hydrogen ion, and usually it has abundance of hydrogen ions, unlike bases. pH stands for potential of hydrogen, specifically hydrogen ions. It tastes sour. When I think of bases, I usually think of household items like soap and baking soda. But in reality, similar to acids, they can be dangerous too.
Like the hand scene from Fight Club?
Exactly. So a base is anything with a pH of more than 7 and accepts hydrogen ions. Usually they taste bitter.
And what falls in the middle of the scale? Water. Water has a pH of 7 and is neutral.
What if the acids and bases mix together? A neutralization reaction happens.
An acid-base reaction, or a neutralization reaction, happens when an acid and a base react together, forming water and a salt.
The ocean isn't just water though, and historically it has a pH of 8.2, but right now it's 8.1.
That might not seem like a lot, but in reality, the scale is logarithmic.
This means an acid with a pH of 5 is actually 10 times more acidic than an acid with a pH of 6.
So, a change as small as 0.1 is actually hugely detrimental.
This phenomenon is called ocean acidification, and it occurs because of CO2 in the atmosphere. The influx of CO2 has been a result of industrialized human-made products like cars and airplanes. But even before humans, there was carbon dioxide in the atmosphere. So how come ocean acidification is a recent issue?
In order to understand the issue, we have to talk about equilibrium. Some chemical reactions are reversible. When this is the case, the forward reaction can happen at the same time as the reverse reaction. As more reactants react to form products, the concentration of products increases and the concentration of reactants decreases. Because of this, more products are able to turn back into reactants. Eventually, this gets to a point where the concentration of reactants and products change at the same rate. This is called equilibrium. What do we mean by equilibrium? Picture a tennis court with one person with all the tennis balls on their side and the other without any. The first person starts throwing the balls over to the other side, and the other person is trying to throw them back. At first, the second person is slower, as they have less balls.
But eventually, there will be a point at which both people will have the same number of tennis balls on each side. This is the point of equilibrium. We can apply the same concept to the ocean acidification. The ocean is taking in more CO2, therefore it has to accommodate for the increase in hydrogen atoms in the form of lowering the pH level. The speed of the reaction dictates what the chemical equilibrium is. There is an equilibrium between the carbon dioxide gas in the atmosphere and the carbon dioxide dissolved in the ocean.
Well, that has to do with something called Le Chatelier's principle. Le Chatelier's principle states that if a change is made to a system at equilibrium, the position of equilibrium will shift in order to counteract that change.
So, in order to counteract the increase of carbon dioxide in the atmosphere, the equilibrium between carbon dioxide in the atmosphere and the carbon dioxide dissolved in the ocean shifts towards the right, which means there will be more carbon dioxide dissolved in the ocean.
Exactly, and when carbon dioxide dissolves in water, it turns into carbonic acid. And the ocean is made out of a bunch of water. So, if more carbon dioxide is in the air, more carbonic acid is being produced in the ocean.
When acids dissolve in water, they lose a single hydrogen ion. This is called dissociation. Carbonic acid is a weak acid, meaning it only partially dissociates. So we know more carbonic acid is being produced, which means more hydrogen ions are being released in the ocean. But what makes it such a big deal?
That's what happens, but just in a less dramatic way.
We performed a lab where we put a shell in a mixture of vinegar and water.
And after 24 hours, we found that it had lost mass.
This is what's happening in the ocean, but on a much bigger scale. Many creatures' shells and corals are made of calcium carbonate. When calcium and carbonate try to bond, sometimes a hydrogen ion will steal the carbonate from the calcium and create bicarbonate. This is because hydrogen has a greater attractive force than calcium.
Before the Industrial Revolution, there was enough carbonate in the ocean to balance out the carbon dioxide being dissolved. But now, with the influx of human-sourced emissions, this isn't the case. Because more hydrogen ions are being produced, there's a massive impact on the pH in the ocean.
Thank you for watching.
And make sure to subscribe because one sub equals one shell.